That I know about that RPO, RTO. We're talking about RAID, right? RAID level implementation in SAN and NAS. Okay. Recording. This is RAID 10. So you have A1, A2, B1, B2, then C1, C2, D1, D2. That's how the data is going. So RAID 2, RAID 4, we don't use that in the environment. RAID 6 we will use. Most of that it will be RAID 10 because of the faster performance. This is how the RAID 10 will work. So you will be utilizing this as a whole, the entire what do you say? Let me copy this image. So what we are doing here is okay, I will copy separately. So we have RAID 1, RAID 0 at this level we are doing, and RAID 1 what we are doing is we are doing at this level. Okay. Assalamu alaikum, Danish.
Walaikum salam.
Okay, at 4 levels, at 2 disks, we will be doing RAID 1, RAID 1. So we will be copying this, striping that. That's how it will give us fast, this one, what do you call, performance. First what we are doing, we will be writing it on 2 drives. So let's suppose this entire disk 1 and disk 2, you imagine it is as one drive. Okay, this as one drive. Okay, what I am doing is I am just striping it. I am just copying the data. So just take A1 here, A2 here, A3 here, A4 here, A5 here, A6 here, A7, A8. Okay, I am striping the data fast. I am writing it. Okay, after that I am doing the copying here. I am doing the mirroring. So why this is fast? Because I am just writing it very fast. I am not copying it. If I am copying it, then I will lose the performance. That's why all the organization will use this RAID 10. You understood now? RAID 10. Yeah, Mohsen. Yeah, Danish. Shemshar.
Yeah, if RAID, if we replace it with the RAID 0 down and the RAID 1 in above, it will be more redundancy, right?
More? No, that will impact my performance.
Okay.
See, if let's say you have I'll take pen. Okay.
No, suppose disk 1, disk 2 fail,
Wait.
then the data will be failed, right?
Wait. I will tell you how it will. So here I have RAID 1 is mirror. Okay. One, if this fails, I will have my data. 2 drives. If this drives fails at this point, okay. If these 2 drives fails, my data is gone.
Yeah, that's what I was trying to say.
Yeah, the data is gone now. So that's why you will have physics in that. Physics is something like you can go on mute, okay. Physics you will have means you will have history of that hard drive. Like you have your hard drive 5 years, 6 years, it's about to get failure. So that's why you will be keep on tracking those hard drive age also. It's likely to get failed. Okay. That will also play a key role. Why we will not put RAID 0 at this level? Because it has to mirror it. At RAID 1, what will happen is you need to mirror that. Okay. You just okay. You just doing the mirroring. Okay. Then you are writing it. First mirror, then write. So in RAID 10, what happens is it will just write first. After that, it will mirror. That's why the performance will be high in RAID 10.
Okay, understood.
Okay. Now we'll go back to our high availability part. So recoveries, these are all mainframes like DB2 resource manager. So for one project I worked on this content manager where I got this data. Okay. So it's all about high availability means nines. It is about all nines. You will have mostly the SLS will be calculated in this nines. So this is the downtime per year, time loss. Okay. If you are having 5 nines, okay, then the downtime will be only 5 minutes per year. If you have 6 nines, you need to give 32 seconds of time loss. This is what the availability matrix is. So the level of availabilities. What are the levels of availability? We'll see what exactly this is. Okay. At level 1, you will not have any redundancy. Let's say we'll see with these definitions. Okay. So you will not have any data protection. It is just gone means you will have outage. At level 2, you will have RAID level. You will have disk redundancy. If one get failed, you will have redundancy there. So RAID level 3 availability is you will have a failure component, like the application is redundant, or you are going to get availability there. If server is failed, complete server is failed, still you have the availability. Level 4 is like data redundancy, like you have database redundancy, you are copying the database. Level 5 is even if the entire data center is gone, you still have that redundancy, site redundancy. These are all these failures. Like in level 3 failure, you will have application clustering or platform clustering. Either you go to you configure the application so that it will work as a clustering, or you do the platform clustering like on IP based. So it at level 3 you will be doing the failure. Okay. Level 4 you will be doing the data replication. We will see in graphical way. Okay.
Why this is the similar way you explained tier 0, 1, 2, 3. Little bit similarities.
Yeah. That is for performance. This is for availability. There is lot of difference between that. So here the data is it should be available. Okay, I am talking about here availability. Here I am talking about performance. The amount of speed I will achieve it, not the failure factor here. If you see, there is no failure. It is all about performance here. There is no availability here. See, all are about the performance. So here we are talking about the availability factor. What if this fails? What about this? So as you move up in the ladder, you will have cost factor. So let's say how we are going to measure the availability. Okay. So you are going to ingest something, or you are sending one file, or your data, logs, whatever you are ingesting it into the network. It is a scan, import. These are very old. Okay. Still it is relevant. Okay. That's why I took this. Maybe this is 20 years old, I guess. Okay. So you are sending the data. So once you are sending, still the data availability is same. Then your ISP, then network, then you are going to firewall, then load balancer, then your web application server, then you are moving back to internal firewall, then application server, then database, then your local storage, then tape backup, then you are retrieving this data. These are all the components or levels that you will be retrieving that data. If you look into here graphical way, this is how it will be. I will enlarge this. Okay. So I have a firewall here, internal users. They are coming to the firewall, internal firewall. Then we have a web presentation layer. Again we are securing this with another firewall so that the contents are secured again. Okay. Here we are copying the contents database into tape drives. Let's say this is a multi-tier physical model. So here we have clients, one firewall, DMZ, and then application. This is one firewall, and this is another firewall. At the data tier, we are taking backup.
Give something, no?
Huh?
To track the vehicle.
Yeah? Yeah, Mohsin? Who is that?
It was not me.
Okay. Okay. Who did you ask anything? Okay.
No.
Okay. So this is a simple multi-tier architecture here. So here the main data tier, you need to have backup here. It should not fail, because all are accessing the data. without data, it will be huge impact. That's why you will have a backup or redundancy at data tier level. So now we will come back to the clustering part. Okay, what if this server goes down? So you have redundancy at this level, failure. So you have load balancers here, two load balancers. So even if one goes down, that traffic will come over here at the tier 2 level. Then you have failure at web application layer. Then middleware here. Even if one goes down, still you have the active and passive clustering here. So you can see here the terminology we are using. We are doing all the clustering here. So we are coming back to the level 3 here. We have failure, right? So we will be doing the clustering part, level 3. Okay, you can see here tier 4. So here you are doing the clustering part for the servers from a TSM server. This will be the backup server. You will fetch the data. Okay, here you have put the data into the shared drive, single shared drive. So we have moved out of storage from these servers. It is not a local storage now, it is on the shared drive. So whoever getting failed, still the data is accessed. This is completely the clustering part. Now we will go back to the other one, like data redundancy. Clustering and replication. So you have clustering here, all these clustering still, and you are doing the replication here. There is not much difference in that. Clustering and replication. If you see here in this, there is one more hot spare here. If this is going down, the library server is having hot spare. Earlier, the library server doesn't had clustered. If you see here in the other diagram, we had only one library server. Okay, if this goes down, means we cannot retrieve the data. There is no hot spare. Still, this will be functional, but we cannot retrieve in case of failure. So here we are doing the library server also. It's a hot spare here. Hot spare means if one goes down, it will take immediately. This is level 4 example. Level 5, it is DR. They kept DR at here. Okay. Now the entire site is being replicated here. So the entire setup you are failing over. This is gone. Okay, let's say the entire site is gone. Now you have replicated all the setup here. The main setup is the database replication. So you have replicated the data and then it got failure to the site B, from site A to site B. That's what failure is. DR. Those are the strategies for implementing this. This is in detail of site A and site B. How this can be achieved? This is the setup. You will be monitoring it at this level, you will be copying the data. All this stuff will be with geographical failure. This is content manager solution. So I just took this example so that you will be correlate and understand it in a realistic way, instead of just doing it on the presentation. I took this as a realistic example so that we will be able to correlate all with our real-time scenarios. Wherever storage is there, you have storage backup and redundancy level. We have increased that. That's all about DR and BCP.